So hello guys, I'm Mohammad Akif Jaman, and in this video I'm going to discuss about the problem called space arrays from the March long challenge to 2021 division 3 of Codechef. For those who hasn't read the problem statement yet, I'm just gonna thoroughly read this. Finally, Progress reached the Madoka family and she decided to play with her little sister in the sensational game Space Ares. The rules of the game are as follows. Initially, a sequence of A, where A1, A2 through AN are the indexes of the given sequence. The players alternate turns. That means at first the first player will uh, choose something, then the second player will choose something like that, and after the second player chooses again the first player will choose something, and this will go on until it doesn't satisfy a condition. So in each turn the current player must choose an index I and increment the AI value by 1. Afterwards, if there is no permutation such that P, where P1, P2 to Pn are the indexes values of the integers 1 through n, such that AI is less than or equals Pi holds for each valid I, the current player loses. This statement is very important and crucial. Uh, so if you guys understand this statement or this line, actually you can easily solve the problem. Even this problem is much more easier than problem C. Otherwise the game continues with the next turn. Madoka is asking you to help her tell her if the first player, the player that plays in the first turn. So they have said you that the first player will always choose the first turn, or second player wins in this game if both play optimally. So the input is pretty basic. You won't have any problem to understand the input. The output is also very easy. You have to print first or second. If the first player wins, you have to print first, or else you have to print second. So test case constraints are 10 to the power 4, and the arrays given sequence could be 10 to the 5, and sum of an overall test cases doesn't exceed 2 into 10 to the power 5. So this line indicates that you have to use a loop. Without loop you can't actually solve this problem. I mean, you can't solve this problem in big of 1 complexity. And the each of the given sequence value could be as long as 10 to the power 5. So there's only one subtask for 100 points, and I will discuss the uh, test cases later. So first let's try to understand the problem. Okay, I'm just going to grab one test case first for 1233. Okay, so in case of the first test case, so like given as 4, so we take 4 indexes value, I mean the sequence value. These are the value of A. Okay, these are the AIs actually. Okay, where this is AI equals 1, this is AI equals 2, this is AI equals 3, and this is AI equals 4. Or else you can, if you consider the array form, then this will be like AI equals 0, AI equals 1, 2 and 3, like that. Okay, so even if you say this is 1, this is 2, this is 3, this is 4, that is also correct. Okay, so this is the form of AI actually. But what is the form of P? Okay, this is very crucial to understand. When we select n as 4, so P will become like 1, 2, 3 and 4. Okay, If we choose n equals 5, then p array will become 1 2 3 4 5, and when we select n equals 10, then p array will become like 1 to 10. I hope you understand that. Okay, so can you guys tell me, like, if there is any permutation of p where uh, the any in any index the previous value is greater than the next value? Like, is there any permutation where, like, is not, I mean, okay, like 1 2 3 4 5, like if I select 4, okay, so is 3 greater than 4? No. Okay, is 5 greater than 4? Yes. Okay, so the next value can be greater, but the previous value cannot be greater. So in that sense, we'll have to consider p as a sorted permutation, right? We can have the permutation like 2 1 4 3 5, but in that case, is it true for all the p of I? Like, this is p of 0, this is p of 1, this is p of 2, this is p of 3, and this is p of 4, right? So is it true for all the p indexes that the previous value is always less than the next value? Like, if we see for these two, 2 comes before 1 and 2 is greater than 1, but it should be like 2 is less than 1, but it's not true. Okay, this kind of relation should happen, like the next one should be greater and the first earlier one should be smaller, but in that in this permutation, this is totally opposite. Okay, and also if we see for these two, also 4 is greater than 3, um, but 4 comes earlier than 3 in this permutation. Okay, so this permutation is not required for us. We need a permutation where the next value will always be greater than the earlier value. Like, if we permute this given sequence, we can get 1 2 3 4 5 like this as well. Okay, where in every I or I plus 1, I and I plus 1, we'll get like the previous value is always smaller than the next value, right? Like that. Okay, so to get this for all the pairs, right, uh, to get this right for all the pairs like 1 2 2 3 3 4 4 5, what we actually need to get, we need to get a sorted permutation, right? Otherwise it's not possible at all. We need to get a sorted permutation, and that's a mandatory thing, that's a must thing. So when we are given an array or a sequence, first what we need to do, we need to sort the given sequence. Okay, this is must. So we need to sort the given sequence first, and then what we need to do, like for 4 we get a permutation array of like this, right? And we need to check like this value and this value should be like equal, right? And this value and this value should be equal, this value should be equal, and this value should be equal, where these two satisfy our condition, these two also, but these two doesn't satisfy our condition. And if we have something like this, so what do we need to do in this sequence to get this sequence from this to this? What do we need to do? We need to make one increase in this index, so we can add 1 to these 3 and we'll get like 1 2 3 4, which will be equal to this permutation, right? So if we have to add 1 in this, we actually playing the game like in one turn we are increasing one value, right? So for this given test case, if the first player chooses this index, as he can't really choose any previous indexes, right? Because he will know the result if it does so. Like if he increases this index value by 1, this will become a 2, and this is not a valid permutation. Why? Because the valid permutation says that the first index will always have the value 1, right? The second index will always have the value 2. So the first player, as he plays optimally, he really won't change the value of the first index. Also, he won't change the value of the second index, as the second index is also correct already. Also, he won't do the same for the third index, but for the fourth index, he'll see that the value could be 4, but the given value is 3. So yeah, he can take a turn and he can make this 4. Okay, so after that, is there any valid indexes to increase? No, because if the second player increases this 1 to 2, like 1 2 3 4, if he increases this 1 to 2, then the permutation won't be valid. Okay, if he increases this 2 to 3, the permutation will be valid, because it should be like 1 2 3 4. Okay, so when actually we get fixed permutation, can't really change anymore. Okay, like for 4, for n equals 4, the maximum value permutation is 1 2 3 4. Okay, so when we get to this point, after that no one can take in turn, right? So what is the logic behind this? Okay, let's see. So in the first at first we need to see, like, if there is any given index's value which is already greater than this p of I, right? Like if I give you something like n equals 3 and I give you like 2 2 and 3. So for n equals 3, let me see, check this, let me write this actually. This is the given sequence actually, and for n equals 3 we get the p array as 1 2 3. So we, even if we sort this, uh, even if this is already sorted, but even if we had to sort this, we will get this sequence 2 to 3, and without even increasing anything, we get the first value as 2, where it should be 1, and 2 is already greater than 1. Okay, and we can't change this position or value actually, because we cannot decrease that value. So in this case, the first player can never take any turn, because the given sequence is already an invalid permutation, so he can't really make any decision or turn, and the second player wins. Okay, so this is important. This is an important observation. Also, like even if we give you n equals 4, so what will be the permutation? 1 2 3 4. This is the valid permutation. Okay, and if I give you the array as like 2 1 5, and no, not 5 actually, like another one, like that. Okay, so if we sort this array, what we will get 1 1 1 and a 2, and the valid sequence is like 1 2 3 4. This is p. Now we have to check which player will win if they play optimally, right? So like the first turn is who gets the first turn. Like if I say this is the first player and this is the second player, so at first the first player will take the turn, right? And he can see that the one and this one, I mean the given array is one and the permutation one is okay, so he won't choose this index and he won't increase anything. And then he will see that the given value is 1 and the permutation value is 2, so he can increase it, right? So he will increase that, so he gets his first turn. Okay, and this becomes like 1 2 1 2, but the value sequence is 1 2 3 3 4, right? And now the second player chooses this index as this is less than 3 and he increases the value, so he gets 1 2 2 2. The value sequence is 1 2 3 4. Okay, the second player also gets his turn. Now the first player will increase this again as this is less than 3. Okay, so he gets his turn as well. And then the sequence becomes like this. Okay, this is always P. Remember that the first one is the A array. Okay, so now the second player's turn. He will see that 2 is less than 4, so he will increase 2 by 1, so he gets 1 2 3 3, and the valid sequence is 1 2 3 4. And now the first player sees that the 3 is less than 4, he will increase it 1 2 3 4 1, and this 1 2 3 4 is like the valid P. I'm saying again and again, the second one I'm writing. Okay, and this is where we are doing the operation, so this is like the A array. Okay, and now the second player will see that is there any indexes where AI is actually less than Pi. Is there? No. So even if sorry, this for this, like this and this. Okay, the second player doesn't get any turn at last, so the first player wins. Okay, so what did we actually need to see if the first player can win or not? Okay, let's try this once again. Given n equals 4, so the P of I will be 1 2 3 and a 4, and the AI is given as 2 1 1 1. So the sorted AI will become 1 1 1 and a 2, right? So we can see with Pi, if I calculate the difference, actually this gives us a difference of 0, this gives us a difference of 1, this gives us a difference of 2, and this gives us a difference of 2, right? And we add the differences, we get a 5, which is always an odd number, right? We can check the odd, like 5 modulo 2 equals 1, so it is odd. Okay, so we first we calculate we sort the given array, then we calculate the differences between the array indexes and the sorted permutation like this, uh, where 1 to n permutation. Okay, then we add the differences, and if the difference is odd, then we will say that the first player wins, and if the differences is even, then we'll say that the second player wins. And in any case, if we get an index where the AI value is greater than the valid permutation value, then it will always result in the form of second player's win, right? Like as we saw in this case. Okay, the first player can never take any turn because this value is already bigger than this value, so the second player wins. Okay, so let's check the other test cases that we are given. Okay, 1233. I think we saw that. 1133. We can check that. So this is already a sorted array, and this is our p of I for n equals 4. We get this. Okay, so the differences are like 0, 1, 0, 1. So we get a difference total of 2, which is even. So the second player wins, and we can see this like that as well. 1133 for the first index. The first player will not choose this, as they are same. First player will choose this and increase it by 1, so you will get 1, 2, 3 and 3, but the validity sequence is like this. The second player will not choose this, as they are the same, but he can change this, so you will get 1, 2, 3, 4, and the validity sequence is also 1, 2, 3, 4. Now, is there any index where the first player can take a turn? No, so the second player wins. Simple as that. Okay, we will see the next. Okay, here we can see the second player wins. Okay, this is right. We have seen the last example already. 1, 2, 2, 1, 5. This is for n equals 5. Okay, for n equals 5, we are given a sequence is 1, 2, 2, 1, 5, right? Yeah. Okay, so what is our permutation array for n equals 5? 1, 2, 3, 4 and a 5, right? And now we need to calculate the differences between these two arrays. So ai and pi both are 1, so differences is 0. Here also the difference is okay, so sorry, we need to sort the atomo array first, and this is not not any um, syntax. I'm just writing this 1, 1, 2, 2, 5, and the permutation is like this. So differences between these two is 0. Differences between these two is 1. Here also 1. Here also 2. Here is 0. So the differences, overall difference is 4, which is even. So the second player actually wins. Okay, and we can actually you can try this, like you can see this 1, 1, 2, 2, 5 and 1, 2, 3, 4, 5. For one, the first player won't choose this, he will choose this and increase this. We'll get like 1, 2, 2, 2, 5. The second player will not choose this, as this is the second value. He will not choose this, as this is the first value. He will choose this and increase it by 1. Then the first player will choose this and increase this by 1. Then the second player will choose this and increase this by 1. And now the first player has nothing to choose, as this is already the valid permutation, so the second player wins. So this is the basic code actually. I mean the basic logic, very simple logic, and I hope I have been able to make you understand this, guys. If you have any queries about this problem, then you can let me know in the comment section below, and keep tuned for the next video, the college life 4, and subscribe to my channel and bell the notification icon to get the notification whenever I post a new video. So yeah, thank you guys, uh, and also my submission got accepted, here you can see. Okay, so thank you guys.